am Okuda from QA Engineering Department of Fukuoka. I will present under the title of QA to improve development process expansion of domain from QC to QA. Let me introduce myself briefly. My previous job was developing web applications at a system integrator company in Fukuoka. For the past couple of years, I've been leading projects and improving legacy sites. For example, we did not have a culture of writing test code, but we introduced Selenium to automate regression tests and changed the work that was managed in Excel to ticket management. While I was working this way, I heard about the vision of the QA engineering office last year, which was to create a new form of quality assurance for Line, and I wanted to take on this challenge, so I applied the day after I heard about it. I joined Line Fukuoka in December last year, and I'm now participating in the Line front-end framework, commonly known as LIF product project, as a QA engineer. What do you think of when you hear the word QA and quality assurance? Many people probably think of testing when they hear the word QA. However, QA is not only about testing, but also about broader quality activities. Today, I'd like to talk about the areas of QA activities that go beyond testing, the roles of QA engineering working in these areas, and the actual activities in projects. This is the contents of today's presentation. First of all, I'd like to explain the vision and mission of Line Fukuoka's QA organization. I will introduce how we are trying to improve the quality of Line. Then, as a QA engineer, I will introduce what I have been working on in actual projects. Finally, I will share what I have learned from these efforts. Before explaining the vision of Line Fukuoka's quality organization, I'd like to start by explaining the history of Line Fukuoka's quality organization and the background of establishment of the QA engineering office to which I belong. This is a chart of the number of projects that the QA organization had been involved in at Line Fukuoka. Before 2014, we were involved in about 10 projects, but with the expansion of Line services, the number of projects we are involved in has rapidly increased to over 100. However, in order to further improve the quality of services, we thought that we should conduct quality activities in broader scope and established the QA Engineering Office, which is separate from the Service Test Center, focusing on test process. The vision of Line Fukuoka's quality organization is to create a new form of quality assurance for Line in order to deliver the best service to our users. I would like to explain the missions of each organization in order to realize this new form of quality assurance. The mission of the Service Test Center is to manage the entire test process during the development phase to ensure product quality in an efficient manner. The mission of the QA Engineering Office to which I belong is to contribute to the improvement of quality and shortening of lead time by enhancing not only product quality but also project quality. Next, let me explain a definition of product quality and project quality. First, let me explain product quality. Product quality is the quality of the software that actually works. In general, the word quality is immediately associated with product quality. It is the quality of software that is tested to determine whether it is good or bad. Through testing, quality is improved as needed. This is a general description of product quality. Next, before explaining project quality, first, let me explain process quality and internal quality. First, process quality is literally the quality of the development process. Specifically, it referred to the quality of development effort and procedures. Internal quality refers to the quality of the design documents and code that are created during the development process. Next, I'd like to explain the relationship between these qualities. The quality of the process affects internal quality. If the quality of the development methodology and procedure is poor, the quality of the design documents and codes created according to them will also be poor. On the other hand, if the process quality is high, the internal quality also improves. And internal quality affects the product quality. If the quality of the design documents and the code is poor, the quality of the software that runs according to the design documents and the code will also be poor. On the other hand, if the internal quality is high, the product quality will improve. The process quality and the internal quality that I just talked about appear in the development process at all stages of the project. So, we call this process quality and internal quality together as the quality of the project itself, the project quality. Next, I will explain the areas of QA and quality assurance activities that we consider to be important. As I explained in the beginning, QA is often used to mean simply testing, but improving product quality through the testing process essentially refers to QC or quality control. QA is a broader area of quality activities than testing, and it focuses on quality improvement in the process of creating products. The process of creating product is, in other words, project quality, as I explained earlier. The mission of QA Engineering Office is not only product quality but also project quality improvement, which means to expand the domain of quality activities from QC to QA, as the title of this presentation includes. Next, I will discuss why we need to expand our quality activities this way. As some of you may know, the more defects are found in the back-end process, the more costly it is to fix them. If it is found in the planning or design process, it can be fixed with only minor corrections. However, if the problem is found in the back-end process, such as implementation testing, it will cause more rework and correction costs. Under these assumptions, suppose we focus only on product quality. The more you focus on product quality, the more rework will occur. To take an extreme example, let's say the quality is a back-end process and the quality of the product will be improved by testing. In a project with such a stance, it is highly likely that the number of initial defects will be high when the project reaches the testing process. If you spend enough man-hours in the testing process, you'll be able to deal with a large number of defects. However, when considering the project as a whole, the cost will increase and the lead time will be extended. In order to avoid such situations, it is important to improve the product quality in test process. As I explained earlier, product quality at the time of testing is affected by project quality. By improving project quality, initial defects in the test process can be reduced. By doing so, we can reduce the cost of overall project and shorten the lead time. Therefore, when considering the project as a whole, it is important to improve project quality. This is the reason why we are trying to expand the scope of our quality activities from QC to QA. Next, I'd like to explain what specific tasks are performed in each area. In the QC area, we mainly perform testing. In the QC area, test planning and test execution. I think this is very easy to visualize. Next is the tasks in the QA area. If you ask us what are some of the tasks of QA engineers, I answer, we do whatever we can to improve quality. This may not answer the question, but actually, we QA engineers don't have a fixed task. Why? If there are 10 projects, there will be 10 different states of project quality and 10 different ways to improve it. If I had to give an example of a task, it would be to analyze quality, find problems, and take actions to improve it. But the actions vary from project to project. So again, QA engineers do whatever it takes to improve quality, and there are no set tasks. QA engineers themselves think and challenge all sorts of things. Let me summarize what I have discussed so far. Fukuoka's product team has focused on product quality and tests. In order to further improve the quality and shorten the lead time, we are trying to improve not only the product quality but also the project quality. This means expanding the scope of quality activities from QC to QA. The Service Test Center, which is trying to make testing more efficient, and the QA Engineering Office, which is taking on the challenge of improving project quality, are working together to create a new form of quality assurance for Line. This concludes introduction to how we are trying to improve the quality of Line. I will now introduce my project. I am going to talk about some example of project quality improvement. I am going to talk about case studies of project quality improvement that I did in a real project. There are 3 examples. First, to set product quality goals. Second is to optimize regression tests. The third is test planning in parallel with design. Before I explain the case study, I'd like to introduce the project structure briefly. First, the PM does the planning, determine the specification of the functions to be created, and design the outline. Based on the outline design, each developer team will work on further detailed design and implementation. The QA team will then test it. The testing done by the QA team is E2E testing, which consists of manual and automated testing. At the time I joined this project, the QA team did not do much work outside of the testing process. This is a brief introduction of the project structure. Now, let's talk about the first case study, setting production quality goals. Let me explain the first part of the case study. A description of the situation. Although we are trying to improve product quality through testing, there was no objective index to measure the quality of our products. In response to this situation, we set a change failure rate as a quality goal to measure in order to facilitate the quality improvement cycle. The change failure rate is a probability of a problem occurring after release and is an indicator often seen in DevOps as a quality value. In the project I am participating in, there are 3 major levels of defects: critical, measure, and minor. I define the change failure rate as a percentage of measure or higher defect that occurred in a release. Next, in order to measure the change failure rate with high accuracy, we refine the defect level. The original definition of the defect level in the project was critical for those that needed to be fixed immediately, measure for those that needed to be fixed as soon as possible, and minor for those that would be released in the next version or later, which was largely based on the subjective opinion of the person registering the defect. In order to eliminate some of the subjective factors in the calculation of change failure rate, the definition of defect level was refined further. First, we divided the concept of the defect level by the function where the defect occurred related to the API or UI, and then we define the defect level. We further subdivided the function according to the frequency of occurrences and the scope of impact. By creating a table that combines functions, frequency of occurrences, and range of influences, we can set the defect level without subjectivity to some extent. I will now explain the positive effects of setting quality goals and detailing defect levels. We analyzed the defects of the past year. During the analysis, we assigned defect levels according to the defect level detail table that I explained earlier. We then analyzed the causes of the reduction in the change error rate. From the result of the defect analysis, we found that the defects were skewed towards certain functions. 33% of the defects were for the same function. The main cause was that the regression test was not done for this feature, even though the specification was complex and often broken, unnoticed due to modifications. So, we decided to incorporate regression testing into the test for the feature in question and tested whether they were broken after each release. By setting quality goals in this way, it becomes easier to run the cycle of analysis and improvement. This is the first example of setting product quality goals. Next, let me explain regression test optimization. First, I would like to explain the regression testing situation when I joined the project. We were conducting regression testing for both C2E, manual testing, and E2E, automated testing. There were two major problems with the regression tests. The first is that we did not know how much regression test was covering our own product features. The second was that manual and automated tests were handled by different members and the tests were managed separately. As a result, while we were aware that some of the tests might be duplicated, we were not able to clearly grasp the situation. I would like to briefly explain how we were actually managing the tests. This is the list of functional tests and deliverables of manual and automatic tests. We were not really aware of each other's deliverables, and we had our own structure to create deliverables. For instance, the function list is a system of categories, subcategories, and function names, while the manual test has subcategories and function names. And the automatic test has no categories and only function names. In addition, there were parts where the category and function names written in each deliverables written in different languages. If you look at each deliverable by itself, there is no problem, but if you look at each deliverable by itself, there is no problem. However, when compared with other deliverables, it was difficult to compare because of the different structure. The reason why it was difficult to see was there was an overlap or insufficiencies. I will now explain how we improved the situation. In response to the situations I have explained, we have made the following change. We revised the structure of manual test against a list of functions. The system categories, subcategories, and function names has been changed to match the function list. After modifying the manual testing system as explained above, the next step was to combine the manual and automated test deliverables into a single deliverable and to classify each test so that we could identify whether it was an automated test or manual test. When we combined them into one, we made sure that the duplicate tests were basically done by automated tests. By making these changes, we were able to reduce the number of duplication of manual and automated tests. You can now see the overlap between manual and automated tests. Finally, one additional improvement was made from here. In the artifact of the feature list, we added a URL to the test results to access the test for each feature. In addition, the feature list is mainly managed by PMs and developers, while manual and automated tests are mainly managed by QA team. We had a situation where members other than the QA team did not know where the test deliverables were. Therefore, we added the URL to the test artifact to the list of functions managed by PMs and developers, so that when they wanted to check what kind of regression testing was being done for each function, they could quickly find it without getting lost.
Now let me wrap up how we restructured the test process. First, we unified the function list and test process. And then we combined manual test and automated testing. Lastly, we enabled access from function list to tests. Each of the changes was very simple. But then, we made an improvement of linking the deliverables which used to be disparate. So we can build the mechanism where we can see deficiencies, excesses, and duplications. There is one more thing we did about optimizing the regression testing. That is deleting excessive test cases. Without criteria, you don't know what is excessive, but what helped me was the detailed bug level table that I talked about earlier. With this level of detail, we see that, for example, the function C with lower priority had 2 granular patterns in regression testing. So we revisited those granular patterns for low priority functions and deleted them. In the entire regression testing, we deleted 30% of the test cases, and the time saved was used for high priority testing. So that was the optimization of the regression testing. Let me now talk about the third test case of test planning in parallel with the design process. Before the improvement, there were 3 challenges. Number 1, test planning was done immediately before starting the test. Number 2, the test plans were shared amongst only a handful of members. Number 3, developers implemented unit tests, QA team executed E2E tests, and we did not know what the other team was doing. Because of that, after the test started, we began seeing the difference in understanding of the subtle conditions and specifications. So, we decided to improve the situation by doing test planning in parallel with design processes. We did 3 things. Number 1, we front-loaded test planning to be in parallel with design process. QA team now understands the specifications early and asks questions of PMs and developers to be able to understand difference in understanding as well as insufficient study of specifications. Number 2, in order to increase the opportunities of understanding such misunderstandings, test plans of QA team is now reviewed by everyone, including PMs and developers. It may sound like it takes time, but we can avoid increasing the time required by focusing on the points to be reviewed and potential problem areas. Number 3, During the review, we decided to share unit tests implemented by developers and E2E tests executed by QA team, especially for the areas of high correlations. And we try to eliminate the possible workload increases. But we improved sharing of information and contributing to efficient quality improvement. So that was about case study number 3. I have now talked about case studies for project quality improvement. Now I would like to share with you my journey of realizing those case studies and what I learned during that process. When I joined 1 year ago, I was highly motivated because I wanted to realize the new form of quality assurance of Line by renewing Line quality culture. But then, when I started, I did know I had to do everything to improve quality, but I did not know what to do. Only time passed, and my anxiety increased. My anxiety was rooted in the fact that I didn't know what to do, and also the gap between what QA engineering teams aim at and what the other teams expected of the team. As I mentioned earlier, the QA team originally worked on test processes alone in the projects. Therefore, PMs and developers expected QA team testing. Under such circumstances, in order to realize the mission of the QA engineering team, I wanted to expand the scope of work outside of testing. Because of such a gap in expectations and what we are trying to do, I wasn't sure whether what we are trying to do would be acceptable by other teams. So now I would like to tell you the story of my journey from such anxiety to the realization of quality improvement. What I did first was to image success. We had to do everything to improve quality. Because of that, I was collecting information in order to find challenges in quality. However, that work was endless, and I wasn't even sure whether what I was doing was leading to realizing the mission. So I decided to come up with 2 definitions of success in 1 year time. Number 1, to be a part of design process and contribute to quality improvement. Number 2, to be able to talk with developers about testing. These are my personal vision, not based on the status of the projects. Still, having these definitions, I had clearer picture of what I should be doing. Number 1 was to understand design processes, and number 2, understand the content of the tests run by developers. While I was thinking we would do everything for quality improvement, was like walking in the dark without knowing which way to go. Initially, my idea was haphazardous in setting those definitions, but these definitions helped me gain some dim lights into the directions of going forward, and that alleviated my anxiety. Next, finding and refining challenges. I made a list of challenges which I may be able to contribute in resolving for quality improvement. This is a list from the perspectives of QA engineering, not from projects. And then I racked my brain to come up with approaches for these challenges. Sometimes I realized that my understanding of the challenges was so superficial, and I was wrong in understanding them. So, I reviewed the list periodically based on the learning and experience through the project works. As time goes by, new challenges emerge in project. Therefore, I still continue to find and refine challenges. And then, improvement work for the listed challenges. So, what did I go about them? I'll take the improvement case studies in projects that I talked about earlier. Now, the optimization of regression testing went rather smoothly. But then, front-loading of test plans in relation with design processes was something QA team was not involved earlier, and setting the quality items related to all the members were difficult to implement. So, first of all, I'd like to tell you how we tackled the quality targets. As I mentioned earlier, we started off from the situation when we did not have quality goals. And the list of challenges included the team building by each team member aware of quality, but I did not know how to realize that. One day, a project manager asked for ideas of setting KPIs for projects. So we started off what items to be included as KPIs. I wanted to build a team where everyone is conscious of quality, and setting of the KPI came as an opportunity. I proposed product quality targets that I talked about in my case studies. And the product, or rather quality targets, were realized in that manner. Next, about test planning in parallel with design processes. As I explained earlier, test planning was done immediately before testing starts, and only a few members reviewed them, and there were no sharing of E2E and unit testing. Then QA team wanted to be a part of the design process and wanted to be able to have discussion with developers, and those were one of the challenges on the list. The only thing difficult was how to do that. But then I came to the meeting of the project manager and developers to fix bugs and prevent recurrence. They wanted to expand unit tests. At that time, I made a proposal of QA team front-loading test planning and doing the review by everybody and sharing the content of E2E and unit testing. So, the test planning in parallel with design was realized in that manner. Improvement for design processes and involvement of all the members in all processes were something I wanted to realize. I was able to make timely proposals based on the list of the challenges and the situation of the projects. So here's my learning. The list of quality challenges represent challenges and improvement for quality from the perspective of a QA engineer, in other words, what I want to achieve, and the status of the project represent challenges which are recognized by the team. Therefore, when you want to change something or make proposals, it's important to combine what you want to do and what the team wants to do, resulting in resolving challenges. Finding challenges for the team requires perspectives of QA engineers as well as the counterparts' perspectives, understanding what they do in their roles. Putting yourself in someone else's shoe is very important in coming out of the anxiety and realizing improvements. Now let me summarize. QA engineering team expanded the quality activities from QC domain to QA domain in order to realize product quality as well as project quality. And that meant overcoming walls between QC and QA and test processes. Overcoming the wall certainly resulted in lots of anxieties. And the anxieties were rooted in the fact that I did not know what would lead to quality improvement of projects. And also, I was not sure whether I was aiming at would be accepted by the project's members. Against such anxieties, I imagined successes, and I started thinking about how to solve my counterparts' problems. So, I was responding to the anxiety about the future and uncertainty about the expectations of my counterparts. That certainly was responses to uncertainty for the future that engineers should face all the time. Imagining success and leading to resolving problems of your counterparts was my way of responding to such uncertainties. I hope such ideas can help improve your projects. Thank you for your attention.